Hi, my name is Kelly Chau, and I'm from Brooklyn, New York, and attend Brooklyn Technical High School. My presentation today is about repetitive transcranial magnetic stimulation, otherwise known as RTMS, in Alzheimer's disease and its impact on apathy. This is a systematic review of current research and possible future directions. Before I get started, it is necessary to define a few keywords in this field. As I go through this presentation, I will be switching on and off of acronyms and full names for simplicity. First off, RTMS stands for Repetitive Transcranial Magnetic Stimulation. It is currently FDA approved for major depressive disorder, and trials are being ran to test it as a possible treatment for Alzheimer's disease. RTMS is a wand that sends magnetic pulses through an induced magnetic field into targeted areas of the brain. Its purpose is to excite and fire new action potentials, enhancing neural pathways in certain regions. The most typical target of RTMS is the dorsolateral prefrontal cortex, which I'll cover later. Moving on, MCI stands for mild cognitive impairment. This is a common precursor of Alzheimer's disease and is characterized by its noticeable changes in the ability to remember, though it is not severe. Like Alzheimer's disease, it is only currently medically treated and there is no cure. Therefore, many studies in this review feature participants with MCI due to its similarities with Alzheimer's disease. The apathy AESC is a psychometric scale that researchers and doctors both utilize to determine a patient's apathy, otherwise known as their motivation. MCI, Alzheimer's, and major depressive disorder all collectively are associated with a decrease in apathy, which is the focus of this review. The exam itself consists of a few questions and will be the baseline of many of the featured studies. AESC stands for the Apathy Evaluation Scale Clinician version. Lastly, the dorsolateral prefrontal cortex is located on the right hemisphere of the brain and is most notably known for its dopamine secretion. In regards to TMS, the DLPFC is the most common target, as featured studies have determined the effectiveness of RTMS on dopamine levels when targeted. Aside from this, there is no clear understanding of its cognitive contribution, leaving a slight gray area of knowledge. Now that I've defined these terms, I will now delve into Alzheimer's disease and the importance of finding new treatments. The bottom right image exemplifies the DLPFC being targeted by an RTMS1 as seen up here, where the pulses are being targeted at a very specific brain region. Alzheimer's disease, or AD for short, currently has no cure. However, there are some available treatments to manage symptoms. The most common is a cholinesterase inhibitor, which inhibits the enzyme cholinesterase and prevents the breakdown of acetylcholine. This leaves acetylcholine lingering in the synapse, which boosts neural transmission between neurons as seen here at the bottom, as action potentials fire across neural pathways. The second treatment is immunotherapy on the right-hand side, which utilizes the immune system to target and clear both amyloid beta plaque and tau deposits in the brain that build up and cause blockages between neural pathways. In this case, the immune system is stimulated, antibodies are created for both amyloid beta plaque and tau, and these antibodies are sent to the central nervous system, in which the antibodies help to clear out these deposits left in the brain. And this pathway can be seen down here on the right. Now, though these treatments are widely used and reputable, they can only manage symptoms and are not really treatments for Alzheimer's disease. As RTMS has been proven to largely improve major depressive disorder, it is an extremely novel and potentially groundbreaking treatment that has the ability to have the same effect on Alzheimer's disease. As seen here, it is efficient and painless, going through short trials weekly. There are minimal symptoms associated with RTMS thus far. It is highly researched and has applications in major depressive disorder and has the ability to enhance neural pathways, therefore enhancing neuroplasticity throughout the brain. Moving on to my actual systematic review, first I will go over the methods. A systematic review was conducted utilizing the PRISMA guidelines, and I have a flowchart depicted on the right exemplifying my process. First off, a search utilizing the keywords apathy, Alzheimer's disease, and RTMS was done through 4 different databases, them being PubMed, Oxford Academic, Google Scholar, and JSTOR. After screening for duplicates and relevance, there are a total of 175 valid results before reading through each article. The search yielded 175 total valid results after screening for duplicates and relevance. After reading through each article, 21 articles were further assessed for eligibility and 10 articles were selected for this review. Moving on to data analysis, I will be summarizing the information that has been gathered from these eligible articles. With the majority of the 10 articles, most patients were tested using a baseline. Throughout most of the articles, the baseline was the AESC, which was utilized to test the before and after of all patients in regards to apathy. Experiments consisted of patients undergoing a several week-long trial of RTMS in which weekly sessions of RTMS simulation were conducted throughout a certain period of time. The majority of participants in this study were older people diagnosed with either mild cognitive impairment or Alzheimer's disease. Overall, the findings of the study revealed that RTMS is associated with lower levels of apathy in patients of AD and MCI. In these 10 articles, RTMS targeted the dorsolateral prefrontal cortex. As seen in the image on the right dorsolateral prefrontal cortex mostly targets memory, which was the most common area of the brain that was stimulated. When stimulated, some studies revealed that action potentials within the brain were triggered, offering a similar effect to a treatment for MCI known as methylphenidate. Following the experiment with RTMS, patients were then tested again utilizing the ASC, with scores improving to up to 11 points in comparison to the beginning of the study, referenced by 2 articles by Padella et al. Moving on to limitations, there are a few limitations associated with these studies due to the fact that this is a novel field. First off, most studies had a limited sample size, with most participants being older males suffering with Alzheimer's disease. Additionally, there is some notable bias in this field, as there are studies that have found some bias within some trials. Placebo may also play a role in these trials, although most studies in this review were double-blind, randomized, and controlled trials. In the future, studies should seek a larger representative population of both Alzheimer's disease and mild cognitive impaired patients. Additionally, more research can be done regarding targeting effectiveness in RTMS, as the dorsolateral prefrontal cortex has not been thoroughly researched. In conclusion, it can be seen that RTMS can have a huge potential in treating Alzheimer's disease, given that it does have a positive impact on apathy. As seen in the featured studies, RTMS typically results in lower apathy throughout individuals with minimal symptoms. Despite being a novel field, there is evidence that RTMS is a potential treatment for Alzheimer's disease due to the results shown. However, more research should be done regarding the dorsolateral prefrontal cortex to further support these results. That concludes my presentation. Thank you. And if you have any further questions, please feel free to email me at kellychau@gmail.com. Thank you.